All right. So let's say we have this website, well, a database really, for reviewing AI models, and we want to somehow integrate it with AI apps like Cursor, VS Code, Claude Desktop, etc. We'll do that by creating a local MCP first, and then we'll use the same core to then create a remote MCP off of it, because the core part will stay the same and it will only be the transport layer that will change. We'll start by defining two tools on our MCP server. The first one is called getModelNames, and what it does is a simple predefined SQL query to return all the names from our AI models table, basically from here, and return them as JSON. The second tool we want to define is a tiny bit more smart. It's called getReviews. It accepts model name as an argument, and it then uses this argument to construct a SQL query which fetches all the reviews for the given model and returns them as JSON. And these both tools, they will stay the same regardless if you use it as a local MCP with the stdio transport layer or as a remote MCP with a streamable HTTP transport layer. And speaking of the different layers, let's look at some diagrams to get a better understanding. Most MCPs today still use the standard I/O transport layer. The way this works is that the local MCP client running on your machine will launch an MCP server, and it will write to its standard input. And the MCP server, again, running on your machine, will respond by writing to the stdout, the standard output, where the client can read it. And it uses a protocol called JSON RPC. As you can see, it's just regular JSON with some predefined fields such as params, method, result, and so on. Writing and reading to standard input and output is all well and good if you have a local MCP server on your local machine, but it doesn't quite work when you have a remote MCP running in the cloud. For that, we need a different transport layer, which is called Streamable HTTP. The way it works is, well, quite simple. Instead of writing to std in, we have HTTP requests, and instead of writing to the standard output, we have HTTP responses. It still uses the JSON RPC protocol for the requests and responses, so nothing changes there. And optionally, you can also stream the HTTP responses, which is why it's called Streamable HTTP. And again, it's important to stress out that the core implementation, that's the definition of the tools and so on, it stays the same. And what changes is whether we connect it to a stdio transport layer or a streamable HTTP transport layer. And one last note, streamable HTTP is still kind of new. It replaced our deprecated service and events, aka SSE, so don't get too confused if you still see SSE mentioned somewhere. All right. Going back to the code editor, let's finish off the standard I/O transport layer. So we've got a fully working local MCP. It's actually just 2 lines of code, and a spoiler alert, it's going to be considerably more for the remote MCP, but we'll get through it. Well, anyway, what I'll do is I first define the transport and then connect it to the server, and that's it really. But before jumping into implementing the streamable HTTP transport, let's first actually verify that whatever we've done actually works. To verify that our MCP server is working correctly, we'll use Model Context Protocol Inspector, which we can launch by npx, and which is something like Postman or Insomnia is for HTTP requests, but for MCP servers. If we open it, we can configure how to connect to our MCP server. In our case, we are connecting to standard I/O MCP server. We want to use ban as the command to launch the MCP server because we're very fancy. We've written our server in TypeScript, and ban works well with TypeScript out of the box. And the argument is the name of the file where our server is defined. In our case, server.ts, and we can connect to the server. Now in this UI, we can list all the tools that are available on our server, which is getModelNames and getReviews. And obviously, we can run these tools. So let's first get the model names, and we can see that these correspond to the ones that we defined here in our database. And if we grab one of the names and paste it into this text input, which is the model name for the getReviews for the other tool that we've defined, we are going to get all the reviews as JSON for that model name. Okay, so it seems like it's going all good, so we can now finally move on to the streamable HTTP transport layer. We won't go to the code editor just yet, however, as Streamable HTTP comes in two flavors, stateful and stateless. We need to take a look at one last set of diagrams to get a better understanding of how it works. And again, we'll start by taking a look at how it works for local MCP servers using the standard IO transport layer. For them, MCP servers are launched by MCP clients and they always have a one-to-one relationship. So a single MCP server only talks to a single MCP client. And that way, the MCP server can maintain any state, such as keep track of the messages being sent, keep track of the number of requests, and so on. And when it does a different instance of MCP server, it will run in a completely separate environment, possibly on a different machine, and you don't need any special state management code for that. As you might have guessed, this gets a bit more tricky with remote MCP servers, because when you've got a remote MCP server running in the cloud, we need some sort of identifiers to identify which requests are coming from which MCP clients. And the way it works is the following. When the MCP client first connects to an MCP server running in the cloud, the MCP server responds with a session ID, and from then on, the MCP client sends requests using the session ID, and the MCP server can then use the session ID, find the MCP server for that given session ID, and somehow use the state that it has, such as the messages, the request count, or whatever, and then it responds to the MCP client. And when someone else with a different MCP client connects to the same server, it also first launches a new MCP server for that given session ID, can also keep track of some state, and then use the session ID from then on to identify the requests and to find the MCP server with that state for that request. And obviously, in production, you'd also want some sort of authentication. And yes, this is a bit convoluted, I admit, but the good news is that we aren't going to be using any of that, as we are going to be using a stateless MCP server. And the way it works is much more simple. Basically, whenever a new request comes in, we simply create a new MCP server just for that request. We handle the request, we respond, and then basically throw it away. And when a new request comes in, whether it's from the same MCP client, whether it's from a different MCP client, it doesn't matter. We always create a new MCP server just to handle that request, then throw it away. Alright, so for our stateless MCP server with streamable HTTP transport, we first need to remove the standard IO transport layer, and then we need to wrap the whole code that creates the MCP server in a function so that we can call it and return it whenever a new request comes in. Now we need to create the HTTP server that will handle the incoming requests. And unfortunately, we can't really use the native bound server, and we have to use Express because the MCP SDK doesn't work well with one request, but it needs the Express request objects. So on that server, we'll register an MCP endpoint, which will accept post requests, which is according to the spec. And in there, we are first going to call the getServer method to create a new instance of the MCP server whenever a new request comes in. We are then going to define a new transport layer, which is going to be the streamable HTTP transport, and we are going to pass in undefined to the session ID generator param, because we don't want any sessions, we want a stateless MCP server. Next, we need to make sure that when the response closes, and I think I imported the wrong response, we need the response from Express. So when the response closes, we want to close the transport, and we want to also close the server. And finally, we need to connect the server to the transport that we've just defined. And one last line, we need to call handle request on the transport. And again, I need to import the correct request type. That wasn't it, this one. And we need to pass in the request, the response, and for some obscure reason, we also need to pass in the request body, even though it can already be accessed just on the request object. I don't know why, but it is what it is. To recap, we get a fresh instance of the server, we create a stateless streamable HTTP transport, we connect the server to the transport, and we pass in the request and response so we can handle the request. And last but not least, we need to make sure to clean up the transport and the server when the request closes. Now we just need some finishing touches. First, we'll wrap the whole thing in a try catch because we are very responsible. And in the catch clause, we are going to return a special code that's compliant with JSON RPC and also compliant with the MCP spec. And finally, if you actually want to run the MCP server, we need to expose it and connect it to a port. So we'll do just that. And I think that should be really it for the code. We can now test it first locally using the MCP inspector, then we can deploy it and we can test it directly in Cursor as well. Going back to MCP inspector, we can now disconnect from the local MCP server and we need a slightly different config. So we need streamable HTTP transport type, and now we need to specify the URL where our server is running. So it's port 3000 and the endpoint is MCP. If you now try to connect, obviously it's not going to work because we need to launch the server ourselves, because that's also one of the differences between streamable HTTP and standard IO transport, where the standard IO is the MCP client, in this case the inspector, that launches the server, but with streamable HTTP we connect to an already running server. So let's go to the terminal and launch the server by running bam server.ts. And now if you press the connect button again, it should connect to the server. And I think this is just some cached UI from before. So if we run the tool again, we should basically get the very same result. And we indeed do. And again, let's copy one of the names of the MCP server, paste it in, run the tool again, and it seems to be working okay. So it's working locally, but we also need to make sure that it's running when deployed. I'm not going to go into the details of deploying because it's essentially just deploying a regular HTTP server. In my case, I'm using render just because it works with BAN out of the box. And to test the deployed version of the MCP server, we can change the URL here. So instead of hitting localhost, we are now going to hit the MCP endpoint on the deployed instance on render. We can reconnect and we can run the same tool again, and it seems to be working again. And finally, let's verify it in Cursor. So we can go to Cursor settings, we can go to MCP tools. You can see that I've already installed it. It's basically just a matter of specifying the URL here again. And if I now open the AI sidebar, I can ask a question about our model Tostados website. So for example, I can say what models are available on model Tostados, and it should be able to figure out that it needs to connect to the server, and it will give me an answer. So it's going to tell me that these are the models available. And then I can ask a follow-up question to also see the other tool, because this only uses the get model names tool. So I want to also see the other tool to get the model reviews in action. And I can do that by asking a question like, what are the pros and cons of the Kronos model? And it should be smart enough to figure out that it needs to pass the exact name of the model, even though I didn't type it out fully here to call the tool. So let's see how it does. And it should also then use the JSON response to construct a more human readable response. And we can see it does that. It says the pros: great at answering time out and temporal reasoning questions, whatever that means, cons, slow inference time, and so on. And I guess if we inspect the reviews, we should see something along those lines as well. And that's it really. So basically, to recap what we've learned, the core part of MCPs, which is where we define the tools, it stays the same regardless if we then connect it to the standard IO transport layer or the streamable transport layer. And for the streamable HTTP transport layer, we can either have stateful with session management, where we keep track of some state on the server and we need to generate session IDs, or we can go stateless, where we launch a new MCP server upon every request. And that's it for today. Let me know if you have any questions or requests for what I should cover next, and take care. Bye.